Hi, welcome to the Signal and Systems tutorial. Today I'll talk about some clue and tips in solving tutorial 1. I will not go through all questions, but I'll be selecting a few questions that I will show you examples on how to solve it, and then you will be able to use the methods that I solved these examples to solve other questions. And let us look at question 1. Question 1 is asking you to express each of the complex number in Cartesian form, and then you can notice that each of them are actually in polar in the complex exponential form. And to change it, you just need to apply the Euler's formulas. So let us try examples E. Alright, and then the rest you should be able to do it yourself. So on example E, you have the square root of 2 e to the power of j pi over 4. Alright, so we just ignore the square root of 2. So square root of 2, we just write it out. And then e to the power of j pi over 4, what is it after you do the Euler expansion? You will get the cosine of pi over 4 plus j, remember there's an imaginary number here, sine of pi over 4. And then at this point onwards, you can actually just press your calculator to find out what exactly cosine pi over 4 is and what sine pi over 4 is. So in this case, if you didn't want to punch a calculator, it's fine also. You can actually calculate out the answer as 1 over square root 2, but it's totally fine. You just press your calculator, cosine of 180 divided by 4, which is cosine of 45, and then you get these answers, which is 1 divided by square root 2. And then if you get decimal answer, is fine also. You can just leave your decimal 0.707 thing. And then this j is the same thing, 1 over square root 2. Alright, ignore this one. Sometimes it has bugs, so it has spikes over there. Alright, and then now just substitute back the square root 2 into it, so you get 1 plus j. And so this is in the Cartesian form already. So the answer is 1 plus j in this case. So you just need to use the same method, the Euler's method, to solve all the 8 sub-questions here. For question 2, you need to express each of the following complex number into polar form. So now you are changing the Cartesian form back to the polar form, which is what you've seen in question 1. So let us choose one of the questions to do. Alright, first we choose, let's say, 1 plus j. Alright, so how do we change this? Alright, 1 plus j to, let's say we have r e power of j theta, and then we need to find out what is r and what is theta. And if you refer to our lecture notes, you'll notice that r is actually the Pythagoras theorems. We just need to 1 square plus the coefficients for the j, which in this case is also 1, and then it's a Pythagoras theorem, so you just get square root of 2 in the end. And then for theta wise is given by the arctangent of your y against your x. So your y is 1 and your x is 1 as well. And in this case, you will get 45 degree. So you can just write 45 degree over here. Or you want to write pi over 4, both are fine. And then therefore now you have the answer. This one is equal to square root of 2 e j pi over 4. So this is the final answer. Alright, there are some other questions there are some other sub-questions in this question that is more complicated, that you need to do one extra step. So for example, we look at this 1 plus j divided by 1 minus j. So now if you look at this 1 plus j divided by 1 minus j, we need to separate out the real numbers and the imaginary number. So it is very difficult to separate out when your denominator has both real number and imaginary number. What you can do is that you can multiply both sides by a set of numbers. So let me illustrate here. 1 minus j. So in order to get rid of this j, we multiply it by 1 plus j, so that we can make use of the formula a square minus b square equals to a minus b, a plus b. So you see this one is a minus b and this is a plus b. So on top you should multiply by exactly the same thing. Alright, these two must be the same. Okay, I shouldn't confuse you with this arrow, but you have to remember these two should be the same. And after multiplication, you can solve it the top part first. 1 multiplied by 1 is 1. J plus multiplied by 1 is j. So you have 1 plus j. And j multiplied by 1 is j. You have 1 plus j. You have j again. And j multiplied plus by j is negative 1. Alright, you have to always remember that. Both imaginary number multiplied by each other is negative 1. So in this case, the bottom one will be just 1 square minus j square. Correct? So the next step will be 1 minus 1, which is 0. J plus j is 2j. So top part will just be 2j. The bottom part, 1 square minus j square, and j square is negative 1, as you known earlier. So in this case, this becomes 1 square plus 1. So it becomes 2. So the answer is just j. So how do we change j to polar coordinates? Alright, you can still put j as equals to r e power of j theta. And then we find out what is all this. So r will be the Pythagoras theorem, 1 square plus 0 square, because there's no real number now. And you just get back 1. As for E, is the arctangent of 1 divided by 0. In this case, you need to draw out the quadrants to take a look. So this one is the real, and this is the imaginary. So this one will be J only without R, so it's here. So it's actually a 90 degree. Alright, so in this case you can draw it out. So this arctangent will give you 90 degree or pi over 2, either one. So the final answer will be 1 multiplied by E J pi over 2. So that's the answer for this question. So the rest of them, please solve it your own. For question 3, we are required to determine the value of powers and energy of the following signals. And let us try with A, and then you can try B and C by yourself. Remember, a signal cannot be both power and energy at the same time. So one very easy way to determine if a signal is power or energy signal is this. If the signal is periodic, it will be power. So I'll just write here first. Power signal is always periodic. An energy signal must always has an enclosed area. Meaning that your graph should be like this, has an area here enclosed, where both ends are 0. Alright, so let us look at questions A. So these questions, if you can plot it out, it's best you can plot it out. If not, it's fine as well. So let me plot out. It's always 0 because of the ut. And then from here is e power to negative 2t. So it will come down this way. So this signal has an area enclosed. So we can safely say that this is an energy signal. So energy signals, if you refer to the lecture notes, the formulas to find out the signal is given by this. The signal modular square and dt from negative infinity to positive infinity. So in this case, our energies for x1, will be integration the x1 signal, which is e power to negative 2t ut, and all this squared out to be dt. Now there is one minor problem here, that is how are you going to square up the ut. So what we do here is that ut is just a signal that tells us it's always 0 when it's before time 0. So before time 0 is always 0. And it's 1 after it's 1 after it's time 0. So what we do is that we just change our limits from 0 to infinity instead. And then we can get rid of the ut. So e power of negative 2t and square up dt. So in this case, it's just simply e power of negative 4t dt. And this is some simple integration where you should be able to get it is negative 1 over 4 and then e power to negative 4t going from infinity to 0. So we just need to substitute infinity and 0 into it. So when it's infinity, so there's another bracket here, okay. When there's infinity, this will be 0 because e power to negative infinity. When it's 0, this will be 1. So at the end, you get 1 over 4 as your final answer. So this is the energy of the systems. There is no power because this signal has a finite energy and also because this signal is not periodic. In question 4, it says that xn is a signal where when n smaller than negative 2 and greater than 4, it will be 0. So it asks you to find out which of the following n value for each of these a to e so that it is guaranteed to be 0. So let us look at just one solution. Alright, a. And then you can apply the same things to work on others. So we want to guarantee that this xn minus 3 is 0. You want to guarantee it to be 0. So what you can do is that the question states that when n is smaller than negative 2 in xn, remember this is in xn. So what we need is this thing smaller than negative 2. And therefore we have n minus 3 smaller than negative 2 and smaller than 1. And the other side, we also have n greater than 4. But remember this n is corresponds to xn, not xn minus 3. So this whole n minus 3 must be greater than 4. So we get n minus 3 greater than 4 and greater than 7. So these two numbers can guarantee that the xn minus 3 will be equals to 0. So you apply the same things to work on the B, C, D, and E. It should be able to be done easily. Question number 5 is similar to question number 4, except that there are some other type of sub-questions that will be asked. For example, if you add the two signals together. So let us try B. Alright, so later C you have to multiply the two signals together. On D you have to multiply the time and then divide by the time. But it's similar to how you solve previous questions and also how you solve these questions. So if you add these two signals together, what you can do is that you can actually separate out to two different parts. So we do the x1 minus t first. So x1 minus t, if it must be 0, we know that t must be smaller than 3 in this xt. So this thing must be smaller than 3. The same formula. 1 minus t smaller than 3. So t, you move it to the side. T is larger than negative 2. Alright. And the other side, x2 minus t must be equal to 0. And it must be smaller than 3 again. So 2 minus t smaller than 3. Alright, t you move to the other side is smaller than, let me erase off this, is smaller than negative 1. So actually if you write it in a proper way, greater than negative 2, this t greater than negative 1. Now you have two answers. However, because you need both signals added together to be guaranteed as 0. So you need to be the subsets of these two answers. Meaning that, let's say if you draw a number line and you have this particular answers negative 2 here and this particular answer negative 1 here. For this, let me use the blue color pen. For this answer, it says that it must be greater than negative 2 here. alright, greater than negative 2. For these answers, another color pen, it says it must be greater than negative 1. And then the overall will be the subsets of both, meaning that both arrow must go through it. So we should make it here. So the final answer is t must be greater than negative 1. Okay, in the next questions, question 6, it is asking us to do transformations on a signal itself. So as you learned before, transformations, they are shifting, time reversal, and then time scaling. So mainly are these three, and these questions, they are A, B, C, D, E, F, consist most of these three already. So I'll just pick one to solve, and then the rest, please solve it your own. So let us pick this C. I usually pick the one in the middle so that the difficulty is in the middle. It's not too easy or it's not too difficult. So I have mentioned it in the lecture as well. When you have the time scaling, this is scaling. At the same time, time shifting, you will have to do the shift first before you do the scale. So what we do is, first, we need to find out what is the shifting. So without scaling yet. Alright, there's no scaling for this question first. So we just do the shifting. So to shift it to +1 is very simple. You just shift it to the left of one step. So everything will be similar like this. Let me try to draw out nicely. Come down and there. Alright, so this is 1, this is -1, this -2, and this -3. So that is the time shifting. And then after you shift, this particular same graph will be undergo time scaling. So when you multiply the time by a constant, you are actually divided. You are actually shrink by that constant. So everything's on 0 remain the same, but everything else are shrink by half, shrink by 2. So 1 will become half, and then this one will go up. This one will become -half, and then go. This become -1, and then it drops, and then go up again, and this point become -1/2. Alright, so that is the final answer. So this one should be a straight line. Alright, so you do the time shifting first, and then you do the time scaling. This is almost the same question as question 6, except that now it is on discrete time signal. So in discrete time signals, there is one very important concept that you should know, that most importantly after your time scaling. Let's say this example. After time scaling, you notice that some of your spike, all this spike, actually falls on not a real number, not a whole number. So let's say, for example, it might fall on 0.5. So all these points, you need to cancel off. Alright, there's nothing that can fall on not a whole number. Everything must be whole number, must be 1, 2, 3, and then -1, -2. It must be whole number. So let us try question C. So you say x scale by 3 times. So everything is actually shrink by 3 times. So if we draw this up, the one at 0 is still remain as 0. Or let me draw with the blue color pen so you can easily see. Alright, the one at 0 is still at 0. Alright, all this actually we can just redraw it, then later on we scale the time. So this is actually become 1. 3 has become 1. Alright, and then this one is 0.5, and this one become -1, remember? 3, because it's shrink by 3 times. Alright, so in this case, this is 0, 1, and in this case, this one will be 1/3, this one will be 2/3, this one will be 4/3, this one will be 5/3. And as I mentioned earlier, anything that fall outside of whole number, it is not considered in the signal at all. So what we're going to do is that we need to erase off anything that fall outside of whole number. So in this case, this point is gone. Oops, I should not delete off the axis. Hold on, let me draw back the axis for you. Alright, I should erase carefully when you're near the axis. This point is also gone. These 2 points, because it's fall in the middle. These 2 points as well. And this point, and finally this blue point. So your final answer actually left with only 3 points that fall on the whole number. Question 8 asks you to decompose a signal into its odd and even part. So if you refer to the formulas that given in a lecture slide, any signals or odds, every signals can be decomposed into odd and even part given by this. So the even part is the xt plus x minus t divided by 2, and the odd part is given by xt minus xt divided by 2. So let us take an example of these questions. Question 8. So first we have our xt here. What we need to do is that we need to draw out x minus t. X minus t is very easy, it's just a reversal. So everything on the right side will come to the left side. So this is 0, this is -1, and this will be -2, and the magnitude will be 1. So this is x minus t. And then now we want to find out what is xe, even. The even signals is given by xt plus x minus t and divide by 2. So you just need to draw them at the same axis. So xt is this, x minus t is this, and you need to divide by 2. So instead of going up to 1, it's going up to half. And so this is 2, and this is -2. So this is the even number, the even signal. How about odd signal? Odd signals is given by xt minus x -t. Alright, there's a negative here that I left out. Xt minus, so we draw the xt first, and we draw a negative x minus t, which is here. And then this again is divided by 2 for the magnitude, so it's half, and therefore here is -half. And again this is -2, and this is 2. So that is your answer for even and odd signal. Finally, the last question is similar to question 8. However, you'll be using discrete signals now. And in this case, again, you need to split it out into xt and x minus t. So in this case, xn and x minus n. So this one is xn. And then we want to find out x minus n. And in this case, x minus n will be, when it's 0, it's still 0, so it's here. And then the rest will be on the left side. So there are a total of 4 peaks, so until -4. And this is 0. Or 5 peaks, or there's infinity peaks. And then after that is -1, -2, -3, -4, until infinity. So this is 1, 2, 3, 4. Alright, now we want to find out the even signal. Again, even signal is given by the xn plus x minus n divided by 2. So when you add them together, you notice one very in discrete signals, you can add point to point. So meaning that this point will be added to this point, and then you find out the final answer here. This point will be added with this point, the corresponding point, and then you get 0 actually. So actually everything else are 0 except at the origin here. And you notice that you still need to divide by 2. So it's 1 plus 1, which is 2, divide by 2, so it comes back to 1. So this is the even signal. The odd signals is given by xn minus xn minus n. So you can do point by point again as well. So for 0, this point 0 is 1 minus 1 and divide by 2, so it becomes 0. So for point 1 is 1 minus negative 1 and divide by 2. So you get 2 divided by 2, which is 1. So it's here. So all the rest follows. So this is actually 1. Alright, so for the negative numbers is negative 1 minus positive 1. So it becomes negative 2, but divide by 2, then you get negative 1. So this is negative 1. Then the rest follow. And so that is the final answer. This is the even signal, and this is the odd signals that is generated from the original signal. That is the end for your tutorial 1. I have uploaded the solutions for every single questions in tutorial 1 into time. So please solve them yourself before you refer to the solutions. Thank you.